Hey guys, today we're going to talk about how to classify matter. On the last set of notes, we were able to talk about different types of matter. Now we're going to classify those types of matter into smaller categories. So remember, matter is defined as anything that has mass and takes up space. Matter can be classified into more detailed categories as well. So even though it has mass and takes up space, we can break down that type of matter or those items that are considered matter into much smaller categories. The first category is a pure substance. Matter is considered a pure substance if it has a fixed ratio of atoms. It cannot be broken down smaller without changing its molecular structure. So matter that is a pure substance can be considered one of two things: an element, where every single atom is exactly the same, or a compound, which is a pure substance that is in a fixed ratio. For example, in an element where every atom is exactly the same, this is something that comes from the periodic table. It is one single item listed from the table, so sodium is an element, chlorine is an element, calcium is an element. So every atom of calcium is exactly like the atom next to it. A compound is a fixed ratio of elements bonded together. So if we look at these three items, sodium bonds to chlorine. Every time you see sodium chloride, there is one sodium and one chlorine. Calcium bonds to chlorine, but every time you see calcium chloride, there is one calcium and two chlorines. If we break this calcium chloride down any further, it just separates again into Ca and Cl. So that changes that chemical substance. So this is as low as it can go without changing what that item actually is. Next we have a mixture. Pure substance is something from the periodic table or two or more items from the periodic table. A mixture is any two substances in any ratio that can be separated somehow. Okay, so there are two types of mixtures: a heterogeneous mixture, a mixture that is easily identifiable, and a homogeneous mixture, a mixture that is blended evenly. So essentially the whole idea here is you take two things, and it doesn't matter how much stuff you have, you mix them together to make a mixture. So if you have coffee, if you only put one scoop of coffee grounds in to make your coffee in the morning, it tends to be a weaker version of coffee. If you put 5 scoops in, it is a stronger version of coffee. If you go to a diner, someone might put cream and sugar in their coffee and someone might drink it black. Those are mixtures because it's still coffee, but how strong it is or what you put into it changes it a little bit, but it's still basically coffee. Other examples of heterogeneous mixtures. Mixtures that are easily identifiable. This can be like trail mix, a mix that has peanuts and raisins and pretzels all mixed together in it. This can also be a mix of salt and pepper. Some restaurants or some places that prepare food may mix them together already to save a step in flavoring your food. A homogeneous mixture is a mixture that is blended evenly. So this is something that looks exactly the same in every section of it. So an example of a homogeneous mixture may be French dressing, because the entire thing is one color. It's all this an even orange color. Another homogeneous mixture may be regular vanilla ice cream. If it has vanilla bean in it, then you're going to have little specks of black, but regular plain vanilla ice cream is a homogeneous mixture because it looks the same throughout it. Types of heterogeneous mixtures. We have microscopic mixtures, where you actually have to use a microscope to see the individual particles and pieces. We have a colloid, which is a mixture with large particles that can be seen with a microscope, but they will not settle out. And we have a suspension, which is a mixture with large particles that can be seen, but they will eventually settle. So examples of these three. Microscopic mixtures. This may be a piece of clothing. If you look at your shirt, you don't necessarily notice all the individual threads that make it up. But if you look under a microscope or a magnifying glass, you can see those threads a lot easier. A colloid, specifically milk, is an example of a colloid. Another one, I would consider blood a colloid because you do have substances that are suspended in blood and you have to use a centrifuge to separate them. Eventually, over time, they will separate out, but it takes a prolonged period of time for that to happen. A suspension would be considered tea or maybe pond water, because when you make a cup of tea, at the end, you may notice that you have some floaties in the bottom of the teacup, some loose pieces of tea that have come out of the tea bag. Those float to the bottom the longer the tea sits on the counter. Pond water or river water is another example. After a big storm, all the silt and dirt from the bottom of the pond or the river gets kicked up into the water, and eventually after the storm, it'll settle back down to the bottom and clear the water again. So those are types of heterogeneous mixtures. A homogeneous mixture would be considered a solution. This is a substance that completely dissolves in another, and the parts cannot be identified or picked out. So an example of a solution would be completely mixed Kool-Aid, because that Kool-Aid powder and that sugar is going to completely dissolve, and we cannot pick out the individual pieces. Another example would be salt water. If you make salt water in a lab and you just mix a little bit of sodium chloride with tap water, you are going to completely dissolve that sodium chloride to the point of having it all disappear, and you won't be able to pick out the little pieces of sodium. Now, these examples, you can evaporate away the water and get that solute, that thing that is being dissolved, back, but it takes a process to separate those substances out. So what we're going to practice tomorrow is identifying the different types of matter, being able to pick apart pure substances versus mixtures, elements versus compounds, or heterogeneous versus homogeneous. We're going to practice it not only in worksheets, but also doing a lab. So I will see you tomorrow.